So this is the fourth video on friction chapter. Okay. So this I'll take up a numerical problem, two numerical questions on kinetic friction. Okay. In case you are new to this concept, then you must definitely watch the first three videos of this. Then you come to this. And if you know the rules of kinetic friction, then you can directly come to this video. Okay. The first question is this. A block slides down a fixed rough inclined plane, and this plane makes an angle of theta with the horizontal. Angle of theta with horizontal at a constant speed. Okay. Now what we have to find out? We have to find out several things. First, the friction coefficient between the block and the inclined plane. When I say friction coefficient, I mean the kinetic friction coefficient. Coefficient of kinetic friction between the block and the plane. B. If this same block is projected up this inclined plane, with some initial speed v0, then after what time will it come to rest? Then after what time will it come to rest? And also time taken by the block to come to rest. And also find the time taken by the block to come to rest. Okay. So this is the question. Fine. All right. I love all this. Okay. So see, solution is this. First I draw the diagram of the situation, okay? This is the fixed rough inclined plane. This makes an angle of theta with the horizontal. Here we have a block, say of mass m, which slides down this inclined plane at a constant speed. Now in first part we have been asked to find the kinetic friction coefficient between the block and the incline, okay? So I draw the free body of the block. Free body is being drawn with respect to ground frame. Only real forces will appear in it. Mg is the weight of the block in downward direction. N is the normal force on the block due to inclined plane. Now this block is sliding over this inclined plane in downward direction. So this surface will exert a kinetic friction F on the block up the incline in the direction opposite to the direction of relative slip. Since slipping is taking place, F will just be equal to mu n. The mu is the coefficient of kinetic friction between the block and the incline. Now, the speed of the block v is constant. I have denoted the constant speed by v. So speed constant meaning acceleration of block is 0, which is simply dv by dt. Since speed is constant, so derivative of constant is 0, acceleration is 0. This means net force on the block is 0 in down the incline and also along normal to incline. So net force on the block is 0 in down the incline. Now this means net force on the block down the incline is 0. Component of mg down the incline will be mg sin theta. The kinetic friction is mu n up the incline. So net force down the incline will be written as mg sin theta minus mu n is equal to 0. Now to find mu, we must know the value of n. Now this block has 0 acceleration in this direction. So along this direction also net force on the block is 0. This angle is theta, so this angle also is how much? Theta. Net force on the block along the normal to the incline is also 0. Because acceleration of block is 0. So net force on the block is 0 in any direction. So in this direction also net force on the block is 0. Component of mg along normal to incline is mg cos theta in this direction. N is in opposite direction. So since in this direction also acceleration of block is 0, net force on the block in this direction is also 0. Therefore we will write as n minus mg cos theta is 0. So n is equal to mg cos theta. Now this n is substitute in this formula. This I rub it now. So n equal to mg cos theta. I substitute this n here. Then we get mg sin theta is equal to mu n. N is equal to mg cos theta. Mu into mg into cos theta. Now mg goes away. So mu becomes equal to sin theta by cos theta, which is nothing but tan theta. This is the answer to first part of the question. So mu is equal to sin theta by cos theta, that is equal to tan theta. That is the answer to first part of the question. Now in part B of the question, what has been asked? We have been told this. This is the horizontal surface. This is the fixed rough inclined plane, which makes an angle of theta with the horizontal. The same block is projected up the inclined plane with initial speed v0. That has been asked to find out after covering what distance will the block momentarily will the block come to rest, and after what time the block will come to rest. These two things we have to find out. I have this first column, okay. Now, so again, what we do first in this case, while the block is moving up the inclined plane, we find the acceleration of block, its magnitude and direction both. Now, for that, what I do, I first draw the free body of the block. Okay. What are the real forces acting? Mg, N, and the block is slipping up with respect to the rough inclined plane. So, rough inclined plane will exert a friction force F on the block down the incline, opposite to the direction of relative slip. Since slipping is taking place, so F will just be equal to mu n, and mu has been determined to be tan theta. So mu is tan theta into n. Okay. So net force on the block down the incline is mg sin theta plus F down the incline. So acceleration of block is while moving up the incline is in direction down the incline. So suppose let us take A is the magnitude of acceleration of the block. Magnitude of acceleration of the block. Okay. So one thing has to be noted, while it is moving up the inclined plane, it's accelerating in downward direction. Okay. Because net force on the block is down the incline. Friction is down the incline, mg sin theta is also down the incline. So net force on the block while moving up the incline is in downward direction, and its magnitude has been taken to be A. Now what I do, I apply Newton's second law to this block down the incline while it's during its upward journey. The net force on the block down the incline will be mg sin theta plus f. That is equals to m times a. Now to determine a, we must know f. F, as I mentioned just now, because of slipping taking place, f is just equal to mu n. Now we again have to determine n. In this, along the direction of n also, net force on the block is 0. Component of mg normal to incline is mg cos theta in this direction, n is in this direction. So net force on the block along normal to incline is also 0, because its acceleration in that direction is 0, because component of a normal to incline will be a cos 90 degree, which is 0. So therefore we write n minus mg cos theta is 0. So that meaning n equal to mg cos theta. Okay, this is a substitute here. Mu is how much? Tan theta. Tan theta into n. Tan theta becomes how much? Sin theta by cos theta. N becomes how much? Mg cos theta. The cos cancels out. This becomes how much? Mg sin theta. Now substitute this f here. Then what do we get? 2mg sin theta is equal to ma. A becomes 2g sin theta, which is down the incline, and it is seen to be a constant quantity. Alright, fine. Now I rub that. Now, while the block is moving up the incline, the acceleration of block is constant, equal to 2g sin theta down the incline. Magnitude of acceleration is constant, is equal to 2g sin theta, and is directed down the incline. Now we have been asked to find out what distance does it move on the inclined plane before coming to rest. Now in upward journey, block is moving up in a straight line with a constant acceleration. So I apply the third formula, v square equal to u square plus 2as. Now when block comes to rest, v becomes 0. U is the initial speed, which is v naught square. Now we know that u, vs all have to be taken with sign. I take up the incline to be positive. Then s will also be positive, but a magnitude of a is down the incline. So a will be taken to be with a negative sign. So instead of a, we write the with sign we have to take minus 2g sin theta into s. S becomes v naught square by 4g sin theta. This is also one answer which we have obtained. Okay. Now we also have to determine the time. For that I use the formula v equal to u plus at. Again u, v and a have to be taken with proper sign. When the block comes to rest, v becomes 0. U is v naught upward up the incline, which has been taken to be positive. So instead of u we write plus v naught. Now a has to be taken with sign. So minus 2g sin theta, because it is directed down the incline. And up the incline I have taken to be positive. 2g sin theta into t. T becomes v naught by 2g sin theta, which is therefore the required answer. Fine, alright. So first question has been fully solved. Alright, clear? See, coming videos which I'll make. First I'll take up all types of problems on kinetic friction. I'll also take up some questions in which was asked PYQ questions in JEE Mains and Advanced. So important type numericals, okay? The first few videos will be fully based on problems of kinetic friction. And I'll also take up problems of PYQ of JEE Mains and Advanced. Okay, some important good questions I'll take up. Okay. Now this are a bit, okay. Now I take up another question, okay? Question 2 of this video. Question is this. A small block of mass m is at rest over a fixed rough inclined plane which makes an angle of theta with the horizontal. Theta with and friction coefficient between block and the incline is mu equal to 3 tan theta. Friction coefficient between the block and incline is mu equal to 3 tan theta. Okay. Two questions are there. Part A. What minimum force F should be applied to the block up the incline so as to cause it to slip up the incline? First part of question is this. And B, what minimum force F should be applied to the block down the incline so as to cause it to slip down the incline? Okay. So this is the question. Fine. Answer should be in terms of m and g, where g denotes acceleration due to gravity. Okay. I love this one. Okay. So, solution is this. First we take the part A of the question. This is a fixed horizontal surface. This is a fixed rough inclined plane which makes an angle of theta with the horizontal. A block of mass m is lying here at rest. Now, in part A, a force F has been applied to the block up the incline to find the minimum value of F so that the block begins to slip up the incline. Suppose the block begins to slip up the incline, okay? Now what I do, I draw the free body of this block with respect to ground. Only real forces will act on it. So what are the forces? mg, weight in vertically downward direction. Normal force N on the block due to the fixed rough inclined plane. Force F which is being applied to the block up the incline. This force is parallel to the incline. Now the block is slipping with respect to surface up the incline. So the surface will exert a kinetic friction F on the block down the incline. Okay. Now the block is slipping up the incline. So it's accelerating up the incline with respect to ground with some non-zero acceleration, say A. So apply Newton's second law to block up the incline. So minus F minus component of mg down the incline, mg sin theta, barabar equal to ma. Now F becomes ma plus mg sin theta plus F. Now here slipping is taking place, so F becomes mu n. Mu is the kinetic friction coefficient between the block and the incline. Now mu is how much? 3 tan theta into n. Now how to determine the value of n? We apply Newton's second law to block in this direction, along the direction of n. So F and F are right angle to this direction, so they do not have any component in this direction. Only components are n and mg cos theta. So n minus mg cos theta is equals to mass times component of acceleration of this block with respect to ground in this direction, which is a cos 90 degree and a cos 90 degree. Cos 90 degree is well known to be 0, so right side becomes 0. So n becomes mg cos theta. Okay, I substitute this n in this formula. In this formula, so F becomes how much? Mu times n. Mu is how much? 3 tan theta, 3 sin theta by cos theta into n. N is simply mg cos theta. So F becomes 3 mg into sin theta. Now substitute this F in this formula here. F is equal to ma plus mg sin theta plus 3 mg sin theta. Okay, so F becomes 4 mg sin theta plus ma. Now we know the block is moving up the incline, so this means the acceleration of block A up the incline is definitely more than 0. This means ma is also more than 0. But from this equation, ma is how much? F minus 4 mg sin theta, which is more than 0. So F is more than 4 mg sin theta. This is the required minimum value of force F, so as to cause the block to slip up the rough inclined plane. So in order that the block is pulled up the inclined plane by means of force F directed up the inclined plane, F should exceed mg sin theta. So this is the minimum value of capital F, so that the block may move up the inclined plane. Okay, this was the first part of the question. Alright, now I love this. Okay, now I take the part B of the question. Now to part B of the question. Part B, it is required to cause the block to slip down the inclined plane. Again, I draw the diagram of the situation. This is the block of mass m. Okay, this is being pulled down the inclined plane by means of some constant force F. Now to find the minimum value of F so that the block begins to slip down the incline. So again, what I do, I draw the free body of the block. mg n F. Now the block value of F is such that the block begins to slip down the incline. So the inclined plane will exert a friction force F on the block up the incline. Because slipping takes place, F will be written as mu n, where n is the normal reaction between block and the inclined plane. Now in this case, I apply Newton's second law to block down the incline. So F plus mg sin theta minus F is equal to the acceleration of block with respect to ground, say B, along down the incline. Now since it is slipping with respect to incline down the incline, so B is positive. This means MB is positive. This means F plus mg sin theta minus F is more than positive. This means F is more than F minus mg sin theta. This means F is more than, F can be written as mu n, mu mg sin theta. This means F is more than, mu is simply 3 tan theta, that is 3 sin theta by cos theta from trigonometry, minus mg into what? Sin theta. Now how to find n? Again we apply Newton's second law to block in direction normal to incline. So F and F do not have any component in this direction. Only mg cos theta is the component of mg in this direction. So in this direction apply Newton's second law. So n minus mg cos theta is equals to mass times acceleration of B in a direction normal to incline, which is simply B cos 90 degree, and we know cos 90 degree is 0, so this becomes 0. So n becomes how much? N becomes mg cos theta. Alright, so this n is substitute here. So F becomes 3 sin theta by cos theta into n. N becomes how much? Mg cos theta minus mg sin theta. Now cos theta cancels out. So F becomes more than 2 mg sin theta. This is the required minimum value of F. Okay. So that the block may begin to slip down the inclined plane. Minimum force F which must be applied to the block down the incline should be equal to at least 2 mg sin theta. Okay. So this example I have solved. As I have told repeatedly just now, some coming few videos will totally be based on kinetic friction problems. I'll also take up PYQ problems from previous year JEE Mains and Advanced paper questions of JEE Mains and Advanced, IT JEE Mains and Advanced. Okay, so you go through these examples properly. If in case you have any doubt, you write it in the comment box. I'll clarify it. Fine. So now I close it here. All right.